Welcome to Chemistry Simplified. Our topic for today is how to draw Lewis structures. And this is part 3, the final part in our installment for this series. And we're covering exception to the octet rule. So far in part 1 and part 2 of the molecules that we have looked over, they obey the octet rule. But we have two examples here today where these two molecules do not follow the octet rule. Here is our first example. Draw the Lewis structure for boron trifluoride, BF3. First thing we need to do is to find the number of electrons that we have available. We use the formula group number, which is the valence electron times the number of atoms. Let's bring the periodic table where we can see that boron is in group 3A. So boron provides 3 valence electrons and we have 1 boron. So 3 times 1 equals to 3 electrons that are provided by boron. Fluorine is in group 7A. So fluorine provides 7 valence electrons and we have 3 fluorine. So 7 times 3 equals to 21 electrons. Together, we have 24 electrons. We need to place the least electronegative atom in the middle. Let's look to see which atom is the least electronegative. Fluorine is the most electronegative atom there is, which is 4. And boron has a 2. The value for its electronegative is 2. So boron should be placed in the middle. So we place boron in the middle with the 3 fluorine. The next step is to draw a single bond between the boron and each fluorine. We need to remember that each bond represents 2 electrons. So this is a first bond, so representing 2 electrons between boron and this fluorine. Another bond. Another bond. So boron has 3 bonds, meaning that it has 6 electrons, and each fluorine so far only has 2 electrons. The next step is to place lone pair electrons on each atom to ensure they all fulfill the octet rule. So let's do so for the fluorine. Fluorine already has 2 with the bond that was formed, so we need to add 6 more electrons. We do the same for each fluorine. And boron has 3 bonds for a total of 6 electrons, so it needs 2 more electrons. So far, everybody's happy by fulfilling the octet rule. However, we added a total of 26 electrons, but we needed only 24. So we have 2 electrons too many. So we need to remove 2 electrons around the central atom. So we're going to remove 2 electrons around the boron. Now previously when we had removed electrons around the central atom, we had used other electrons to form double bonds, but not in this case. because boron only needs 6 electrons. So boron does not get to fulfill the octet rule. So this molecule is said to be electron deficient because boron only has 6 electrons. It did not fulfill the octet rule. So boron trifluoride is an example of Lewis acid because boron can fulfill the octet rule by reacting with another molecule such as ammonia, which would be a Lewis base that would provide it with the electrons that it would need to fulfill the octet rule. We had covered Lewis acids and bases in previous presentations. You could refer back to them if you have further questions about it. Example number 2. Draw the Lewis structure for xenon tetrachloride. We need to find the number of electrons we have available. Bring the periodic table. Xenon is in group 8A, so it provides 8 electrons. We have one xenon, so 8 times 1 gives us a total of 8 electrons for xenon. Chlorine is in group 7A, meaning that each chlorine provides 7 electrons, and we have 4 chlorine, so 7 times 4 for a total of 28 electrons. Altogether, when we add them, we have a total of 32 electrons that we have available. We need to place the least electronegative atom in the middle. The value for xenon is 2.6, whereas the value for chlorine is 3. Therefore, we need to place xenon in the middle. The next step is to draw single bond between xenon and each chlorine. We know that each bond provides 2 electrons, so therefore xenon has 8 electrons since it has 4 bonds around it. We need to place lone pairs around each atom to ensure that it fulfills the octet rule. So xenon already has 8 electrons. It has fulfilled the octet rule. So we only need to place lone pairs around each chlorine to ensure that they also fulfill the octet rule. Right? Since this chlorine already had 1 bond for providing 2 electrons, so we add 6 more electrons. We're going to do the same thing for the rest of the chlorine. Mm, 6 electrons, 2, 4, 6. So now everybody fulfills the octet rule. They're all happy. However, we added only 28 electrons in total, but we need to add 32 because that's what we found when we add all of the electrons provided by the chlorines and xenon together. So we need to add 4 electrons around the central atom. Just like if we need to remove electrons, we remove them around the central atom. So if we need to add extra electrons, we also have to add them around the central atom. So we need to add 4 electrons around xenon 2, 4. Now, xenon has 12 electrons, so it goes beyond the octet rule. Therefore, we would say this is an example of a molecule which does not obey the octet rule. Elements that are in period 3 or higher have empty d orbitals which they can use to place those extra electrons. So this is a topic we will cover in future lecture where we will show you what do we mean by empty d orbitals. This is the end of our presentation for today. Please remember to like, subscribe, and share, and use the comment section to let us know if you had found the presentation to be useful. Thank you. Have a great day.